Hi everyone, this is Babaiah, Assistant Professor of EC Department, MLR Hyderabad. Previous lecture, we discussed about the block diagram and also what are the basic elements available in the block diagram, what are the operation for the each element in block diagram. All these are we learned for the previous session, right? But today we are going to learn some what are the rules to apply for the block diagram that are used to reduction the block diagram, and finally we get the transfer function of the block diagram. We need to calculate the transfer function, right? We need to calculate the transfer function by applying the some block diagram reduction rules. Now we are going to learn all these for the today session. Next, coming to the some of the rules, just here first rule is coming to the first rule is by using the why we are going to study the rules by using the rules by applicable. What are the rules are available in block diagram reduction, algebra or else rules? What are the rules we have? That rules are applied to the any block diagram reduction. After that, finally we get the or else we are going to calculate the transfer function of the control system or transfer function of the given block diagram, right? Here now we have a more number of rules are available. Nearly 11 rules are available. The first rule is used to series when the any series combination of blocks are available in block diagram. The two blocks are again multiplied or two blocks are multiplied into the single block. That representation as the elimination or combine the series blocks in a block diagram. The first rule is combine the series blocks are cascaded blocks. Series blocks are cascaded blocks. Just I am going to draw here one block is like G1. I am going to apply the one input signal A, and one more block has some G2. G2 is there. These two are in the form of series combination. Now we are going to reduce this series combination into the single block. We are going to representing these two blocks, combine these two blocks into the single block. Just here observe, these two are again I am going to converting. Just what is the value? A output of the G1 is AG1. Output of the first block is AG1 and second is the AG1 and AG2. Here AG1 into G2. These two are just multiplied. This is our output, or y equals to some AG1 into AG2. Now we are going to reducing these two blocks into the single block. These two blocks into the single blocks. Just here these two blocks again combined into the single block. I am going to write this two blocks into single block. Just A is my input signal and G1 G2 are multiplied. The output of this signal is same, AG1 and G2. There is a no change. When we are going to write the two series blocks into the single blocks, the two series blocks values are gains are multiplied into the single block. Here just single block, same output here also. If you are going to write these two series blocks combined into the single block, both the outputs are same. So there is no problem to convert the or else combine the two series blocks into the single blocks by apply the or else by use the multiplication. Here just multiply the two series blocks gains. G1 is first gain and G2. These two are the gains. Just here observe. This is the first rule. The combine the series blocks into single block. single block we are going to consider, or else we are going to draw, or else cascaded also same, series and cascade both names are same, right? Next second rule is just the second rule, block diagram reduction rule. The second one is, if the any two blocks are in parallel, combine the parallel blocks, combine the parallel blocks into the single block. Combine the parallel blocks. Just here I am going to draw like this. The first block is G1. I am going to apply the one input signal, and the same signal apply to the second gain G2. Okay, the arrow mark is the indicate the direction of the signal flow. It is very important. Direction is very important. Now these two signal are just adding here the summing point. Here, just adding. What is the output here? Just here observe. The same signal applied to G1. So what is the output here? AG1. Next here, what is the output for second block? Here same signal A and G2. So AG2. These two are combined here in summing point. After the output is AG1 plus AG2. Nothing but A is common, G1 plus G2, right? If the any two blocks are in the combination of parallel, or is in two blocks or more number of blocks are in the parallel form, then we are going to use just adding or else addition. Just add the two block gains G1, G2, G1 plus G2 to the input signal. G1 plus G2 into input signal. This is the combine the parallel blocks. Now we are going to just this one is converted or else reducing these two blocks into the single block. Here just I am going to write here this one. Single block is representation. These two blocks just adding. The input signal is A and G1 plus G2. I am going to write like this. Then output equals to what? A of G1 plus G2. Both are the same, right? Both are the same outputs. So we need to write, when we are having the two blocks are in the parallel, just we are going to add the two parallel blocks gains into single block. Okay, this is the rule for reduction of, or else reduce the blocks which are in the form of parallel, right? We need to write the single block, just adding the two parallel block values simply. Next, third one, coming to the third rule, rule 3. Take up point or else branch point. We consider now take up point. Moving the take off point or branch point. Take up the moving the take up point or else branch point after the block. Right. Now I am going to consider just here one block is available. Just I am going to write the G. My input signal is A. And block is G. My take up point is here. I am consider take up point. This is the take up point. Now I am going to use this take up point, moving the take up point or branch point after the block. Now I am going to, this one is move into the after the block. Here the output is here same signal, right? Same signal means here A. Here also A only. Here A signal is same. What is the output? AG. Here Y equals to AG, right? A equals to Y equals to AG. This one I am going to move this summing take a point after the block. So after the block means here just when we are going to moving the take up point after the block means what we are having the block value, that value is just 1 by that block value in the take up point. This is our take up point, right? This is the block value. Now when we are going to move the take up point after the block, what is the value of the block value? That will be directly in take up point, just 1 by that block value. Just simply I am going to this consider as, I am going to draw this one into the here G, input signal A, take up point. This take up point come to here after the block. So after the block. So what is the value here? Here this one is the AG, and in the block is G 1 by G, and here A is same input signal 1 by G. So here 1 by G and AG value, same input signal. Just I am going to consider take a point, just move to here, just simply, or else I am going to write like this, or else here this one also no problem. 1 by G, here A, okay, here A, same signal. This one is AG into 1 by G, into 1 by G. Finally we got the AG. After the moving the take up point block G, input signal A, the output is AG, the same signal. This one is moving to here in block value. G is there. So 1 divided by block value is G. Just I am going to write like this. This is the AG into 1 by G. Here output Y equals to AG only. The same signal is applied to the block 1 by G. So 1 by G, AG into 1 by G. AG into 1 by G. G both are get cancelled. The finally we get the value A. Here A is there. So here also after the take up point, before take up point is having the A value right here. Same as if moving the take up point after the block also, we get the same A value. There is no change. So the rule is applicable, right? If the take up point is moving after the block, what is the value in the block value? That value is just 1 divided by that value is added in the take up point. Just in block G is there, in take up point 1 by G. So finally I got the A value and output is AG only. Here also output is AG. There is a no difference. So this rule is applicable, right? Next, coming to the rule 4. Moving the take up point or branch point. Moving the take up point or branch point before the block. Previously after the block, now before the block. Here now I am going to consider here just one block, here take up point, block value is G, input signal is A. Now moving the take up point or branch point before the block. So we have here value is, or else I am going to write like this also, no problem. output is AG. The same signal applied to here, so AG only, right? Here the output is Y equals to AG only, here also. Now we are going to moving this take up point after before the block, right? Before the block. Now I am going to moving this take up point before the block. Now I am going to moving this in black value G. Take up point is what is the value in block G only. But before the block moving is what we are having the value in block, that value is as it is, or else that value is directly moving, or that value is where I am going to write in the take up point. Just the same as I am going to write G. So here A, same signal, and here what is the output? AG only, right? Same. Here also AG. After the block, before the block moving also, we get the in take up point AG only. Here also AG, and here also AG, right? Same. Here the output is what? AG. Output is AG. There is a no change, right? Same. So this rule also applicable for the reduction the block diagram algebras, right? Here before, when we are going to move the take up point after the block, means in take up point we are going to write the block value is denominator. That block value is in the denominator. But here in before the take up point, means before the block we are going to move the take up point before the block, means what we are having the block value, that value is directly right in the take up point. Okay, now just opposite, moving the take up point after the block, before the block, but the two are the just opposite operation, right? Opposite operation, but they are same output. Here the same output, so this rule also applicable. These are the 4 rules. Next, coming to the 5th rule, just rule 5. Moving the summing point. Now I am going to consider the summing point. Summing point after the block. Just I am going to write here summing point. Take the summing point 1. Input signal is A. Next again one block is G. Here also I am considered as one input B, A plus B. Here output is here A plus B. That output is applied to the block AG. What is the output after the block? A plus B into G. This is the output. Y equals to G of A plus B. Right. Now I am going to shift, or else I am going to moving this summing point after the block. Is this summing point I am going to move after the block. Right. After the block, just I am going to redraw this one. Now first is block, after that summing point, the input signal is A, this is output is AG, and in take up point, B is there in take up point, B is there, but in block is G value. Block I am going to write just G, and here B value. B and B and G. This is the output BG. Here adding just here observe AG plus BG. What is the output here? AG plus BG. Nothing but Y equals to G common A plus B. Both are same. Both are same, right? So we need to write. We are write like this also. The moving the summing point after the block. After the block means the summing point. What we are having what is the value in the block value, that will be same as adding in the summing point. Which summing point we are going to move? That summing point just adding with the block value. Just here see observe. Here take up here summing point input signal is B. I am going to shift this one to here. So G is our gain. That will be just adding in the this, right? Like this we are going to reduce the block diagram. These are the same outputs, right? So this rule also applicable. This rule also applicable. Next, here just observe, for take up point after the block is division. Block value is just 1 divided by block value. But here summing point after the block means same as, right? Now rule 6. Rule 6. Moving the summing point. Moving the summing point before the block. Before the block. Before the block. Now block is there. Input signal A and summing point. Block value G. So here AG is our input and here one more input is some B. So what is the output here? AG plus B. This is our output. Now I am going to moving the summing point before the block. Before the block. This summing point move into the before the block. Now just observe. First I am going to write the summing point. Because of this summing point is moving to the before the block. Before the block. Right? Here input is A and after that block. Next here input signal. Just here this one is G. What is the block value? G. Now summing point is moving to before to the block. So before to the block means what is the value in the block? That value is 1 divided by that value we are going to write in the second signal. Second signal is this one, right? 1 divided by G. Here B is the signal. So what is here output here? B divided by G. A plus B divided by G. Here A signal is adding with B divided by G. Here what is the output here? A plus B divided by G into G, right? Just here this one A G plus B G divided by G. G both are get cancelled. So what is the output here? A G plus B. Same output, right? Same output. So this rule also applicable for to reduction the block diagram algebra or block diagram reduction, right? These are the 6 rules are important to reduce the block diagram. And next class we are going to learn the remaining rules. I think just here observe. I think you understood every rule. Just 2 blocks are series, so just to combine multiplication. If the 2 blocks are in parallel, just adding. If the take up point is moving after the block, what is the value in block, that value is in the take up point, just denominator, right? If the moving the take up point before the block, what is the value in block, that value is directly same as in the take up point, just we write, observe. Next, moving the summing point after the block. After the block means here in second signal, what is the summing what is the value in block, g, right? That g value is in second value, just same as it is, but before 1 divided by the block value, we get the same output. These are the rules to use, reduce the block diagram and then calculate the transfer function of the block diagram. Thank you all.